All right, good afternoon, everyone. Thanks for staying till almost what I hope is not the bitter end of the conference. This is a paper that's with what I'll call the dream team, lots of very good co-authors from Minnesota and ISB. And we are basically trying to solve a problem that I've been tackling for almost like 2 decades now, which is trying to get MBA students and also by extension, executives and executive MBA students to get better at doing analytics. And the question is, can agentic AI help us do that? All right, so that's kind of what we are getting into. It turns out that overall, I think many of us have these types of courses, I'm sure. But if you look at what some of the industry reports say, with respect to how companies are able to leverage the data that they have to get some insights, it's pretty sobering, okay? So maybe we're not doing that great a job in educating these MBAs in how to leverage this data, because these are the people going out in the workforce, the variety of reasons. And it was one of the big motivations for Anindo and I to write our book, Thrive, and the idea was there to sort of give a framework, which actually we call basically the house of AI. And one of the big messages of that framework to begin with is that even though Gen AI has all the hype today, right? Just last week, the CFO of Meta said that actually they are getting much more value still inside Meta from what we may think of as traditional AI, and just being able to do prediction better, for example, right? So in our book, we have this framework, and many of us, including me, teach courses to MBA students that cover many components of this. And the particular context for this study is going to be a core course that was newly introduced, newly made core at the Indian School of Business, which is a top 30 business school in Hyderabad, in India. And that course essentially covered these 2 pillars of the overall house of AI, right? So the descriptive analytics and predictive analytics. And our question is, for these audiences that don't really want to look at Python code or R code, right? Because half of them are poets, as so-called poets, right? I don't know how good poetry they write, but can we help them actually, again, when they go into the organizations, get value from data out there? Okay, another sort of myth that goes along with sort of the overall story of the landscape right now with analytics and data-driven decision making is that many people think that the barrier for companies to do this is actually the lack of data scientists in lots of companies, traditional companies, right? So leave aside like the top 100 tech companies in the world, right? Look at everything else, right? So in Minnesota, we have what we call the real economy, 19 Fortune 500 companies, in retail and manufacturing and ag and supply chain, right? So for those types of companies, sometimes they think that, the main barrier is actually hiring data scientists. But we argue, Anindo and I argue in our book, is that the bigger barrier actually is the demand for good projects and those capabilities inside the companies from the leaders and the executives and the managers, right? So if the managers don't know the art of the possible, they're going to really bore the data scientists that they hire from high-profile programs like ours. Actually, this is a real story. I was with some alumni from our MSBA program, and I asked her, how's it going? She had a great job. She said, Prof, I'm loving my job, real salary, bought a new car. And then after another drink, I asked her, how's it really going? And she said, I'm really bored. They're making me run things in Excel. You taught us reinforcement learning and, agentic AI and all these things. We're not doing any of that inside this, $300 billion healthcare insurance company. Okay, so that's the reality. All right. So in terms of the research gap, we haven't seen any research yet on deploying agentic AI capabilities to improve basically managers' ability to harness data, right, to do analytics, okay? And we're going to proxy managers out here by basically soon-to-be managers. These are MBA students in a high-stakes environment. The high stakes out here basically corresponds to the fact that this is actually a core course, okay, in a top 30 MBA program. Most of those people who join that program come with the ambition of, joining, maybe some tech companies or McKinsey or BCG or Bain. And in India, one of the cutoff rules that the big four consulting companies use to even interview people for those kinds of jobs is basically their core terms GPA. All right, so it becomes really, really important. These students fight for every point in the core courses, and so what we want to do is we want to kind of fill this gap, and we want to go beyond this idea that we can maybe do an A/B test where in some settings we give people Gen AI, and in another setting we don't give people Gen AI, and then we can look at some outcomes. We actually really want to understand for how do the people use it, and for whom the benefits accrue if they do, and how does it help out there, right? So we want to go beyond a little bit of sort of just binary, do they have access to the technology or not? And the other thing I should mention out here, which sort of maybe I was building up to, is that in this kind of a high stakes environment, even though I try to do randomized controlled trials wherever I can, it's actually really, really difficult, right? If, for example, we found, like we do, that this technology actually helps these MBA students do better, learn better, and then people find out that they were in the control group, they would literally come and shoot me, right? Because they probably will blame that their lack of getting that McKinsey interview on being in the control group of them. Okay, so that's the reality. All right. The questions that we want to specifically address, can an agentic AI-based virtual data scientist, so we're going to build this capability, I'll show you exactly what it looks like, help MBAs develop stronger analytics capabilities, and in particular, we want to focus on the application of analytics, okay? And I'll tell you what my outcome is, how do we measure that, okay? And does learning improve with the intensity of the usage, right? So basically, imagine our ability to measure how intensely they use the technology. We also have access to all the prompts, and then we're going to score, essentially, we're going to give them in the end a pen and paper final exam that has two sections. One of them is on the technical side of the analytics, and the other section of the exam is actually on, it's a case-based section, which is getting them to apply the right kind of analytics to solve the right kind of business problem, right? And that's really what we want to try to zoom into, okay? Obviously, as many studies have done today, is there heterogeneity? Does it help, the low performers or the high performers more? That's always of interest. And then also, can we get to the specific mechanisms that link the usage, agentic AI usage with the outcome, right? So it's basically an intensity kind of story, intensity of usage and the nature of usage that we're going to get into, all right? So quick punchline, what do we find? And then I'll get into some of the details. We do find for the average user, there is an economically significant benefit. If they double their intensity of usage of that agentic AI, they actually gain enough percentage points in their final exam score that might get them from, let's say, an A- to an A, right? So there's actually a material effect. We also find that actually low performers use the agentic AI technology less, but conditional on usage, they actually benefit more, which is very interesting. We find that, we call this like going to the gym mode. You could use this technology, and once you see it, you'll get a sense to, for example, just rotely prepare for the exam. You can use it as a tutor, or you can use it to do the casework that we do, that we give them in an MBA class. And what we find is actually the benefits accrue from, going to the gym, to actually doing the casework, right? That's what corresponds to the improvement in performance. And it's not a whole bunch of other things that you may start worrying about, conditional on the fact that we can't run an RCT out here, right? We have to deal with observational data, okay? Again, because of that high stakes context that I was telling you earlier, all right? Okay. So I've already told you about the context a little bit. To be specific, the class covered essentially some of the core algorithms that you might teach, somebody starting out on this journey in descriptive analytics, right? So association rule mining and clustering, some core algorithms in prediction with binary outcomes and numeric predictions. And the most sophisticated thing we do in this class is basically NLP. So I have this really fun case on teaching students how to detect fake reviews from real reviews. So I have a real data set with actually verified reviews written for hotels. And then we have, it also has correspondingly really genuinely fake reviews that were written by giving people money to write the fake reviews, and we told them that we'll only sort of pay you if they actually look real. So that's the most sophisticated thing that we do in the class. It's basically bag of words kind of NLP, okay, classification. All right. So the platform that we gave them is basically a platform that two of my superstar top coder colleagues, Ahmed and Mochen, and I have been working on now for more than a year. It's called Mentorica. It's basically, the whole idea is we want to train people going into an AI-powered workforce to work with AI agents. Right? So we want to sort of build that capability. It's a platform many people in the room, I think Indy, Wen, others have used it. It's being used pretty widely. Actually, this is a small list right now. It's grown quite a bit. So there's Tulane, there's a bunch of other places where it's been used as well. So just to give you a quick sense, I'm going to show you a little bit of how this platform works actually, right? So those of you interested in the architecture, it's basically our front end, our sort of RAG setup with all the context and the cases. So those 5 cases that I was telling you about. So imagine like that fake review detection case. We have the data. The agent knows the data. It knows the narrative of the case, and that's set up in a RAG architecture. The students will use this platform to give prompts. Those prompts will go to essentially OpenAI, that will generate the code. It will go to code interpreter, which will generate the Python, execute the Python. It'll get it back to us, and we have a lot of sort of guardrails and other things to make the user experience really seamless. Okay, so just to give you a quick sense of what this looks like, I recorded myself and sped up the video in 2x, so it'll sound a lot like garbage to begin with, but you'll get a sense of what's going on, and I'll pause it in a couple of key moments to give you a sense. All right.
Using the Agentic tool.
So this is the one of the binary classification cases. It's the cancer detection case. Each user has basically a channel corresponding to a case. They come in here and type prompts. This first prompt was, please describe the case. So it's telling you, it's kind of this very classic Wisconsin cancer data set that if you've used that, I really like this actually. So they come in and type a prompt. The first prompt was, please describe the case.
Relates to the development of predictive model for cancer detection using binary classification. The data set comes from Wisconsin, a diagnostic breast cancer. It has 569 observations. Each observation corresponds to a features calculated from digitized images of fine needle aspirates, FNA of breast mass. The aim is to predict whether a tumor is malignant.
This is describing the data, describing the features.
The target variables to possible values.
Describing the process.
I'm going to ask you to show me the first few rows of the data. Can you show me a few rows of the data?
Show me the few rows of the data. Give me some summary stats.
At least like my bad typewriting, no problem with that. And then once it does that, I'm also getting ready for my next command, which is, can you please give me the summary statistics? So you can see the first few rows of the data out here. Summary statistics of the summary statistics in tabular form. Are there any missing values? So I'll get to work to do that. And once I've seen that, I might be just ready to go ahead and build it, series of predictive models, right? So can you help? You can see the summary statistics out here. There are no missing values, which is great. Can you build some models to detect cancer and choose the best model?
So, yeah.
Good metric. Let's know this happen.
So that last prompt was, can you build some so very MBA speak, right? Can you build some models to detect cancer and choose the best model on good metric, right? So like, what is good, what is best? Who knows? Like, that's the whole point, okay? So we want to give them sort of this environment, okay? So that's what the tool, and so they have this kind of an agent for all the different cases that we have, okay? So hopefully you got a sense of what we're trying to do. So we worked with the ISB IRB process, got access to some really, really good, very rich covariates that allow us to identify our main effect, because I'm sure all of you who are like part of the endogeneity police, are thinking about all kinds of other things. So here, basically, our sample size is 425 students. We have about 17,000 interactions with the agent. So the fun part about using this tool, as opposed to, let's say, students going to ChatGPT or Cloud or any other tool and doing, maybe with the data set they could do similar things, but you as an instructor have no idea in terms of what you're doing out here, right? So here, everything is in an environment that you as an instructor can go in and get a summary of like what are people doing to learn let's say natural language processing out there, right? So we have access to all these tools, to the prompts that were given. Students, interestingly, because it's an MBA class, they also actually are part of teams. So you can structure this where they're actually solving this case in a team, okay? And this has some relevance later on to identification. And then each group has a separate channel for each of the group's assignment cases, okay? Our outcome is our analysis is at the individual level. The final outcome is the exam score on a pen and paper final exam that, like I said earlier, had two parts. It had kind of the more technical side, like what's the difference between precision and recall kind of stuff. And then it had actual cases, and they had to say, to solve this, I might actually have to go out and apply maybe a binary prediction model out there, for example, right? So it was a tough final exam. The average grade was about 73. The class is pretty well balanced. Over the course of these cases, the average student basically gave about 34 prompts with the tool. And one key variable for us, for our initial identification actually, is that we got access to their prior term CGPA, okay? So this was a term 3 course. We have access to their term 1. We have access to their term 2 CGPA. We also have access to their GMAT, GRE scores. We know a lot about what industry they worked in and so on and so forth. And this is going to become, really like a good first step for us to control for other possible, simultaneous drivers of both usage as well as performance out there, okay? So we're going to rely on that. We're going to do a few more things as well, okay? So if you believe my initial identification, at least with this previous GPA as the main control, then what do I find? I find, when I look at the overall score in the exam, I find a significant average, significant main effect, right? So basically, all the users, typical student benefits, and they get if they increase their usage. Actually, this is a log to the base 2. So if they double the usage of the tool, they would get an additional 1.56 points, which, by the way, as I was saying, is more than the difference between an A- and an A, for example, right? So it's basically material for them because they're fighting for these CGPA points out there. Okay. The other thing we find, as I was saying earlier, is that low performers use it less. How do we measure low performers? Remember, we have access to their prior GPA, right? So we can basically just use that, a continuous value of that, and we regress it. So low performers use it less, but conditional on usage. When we interact their previous GPA with the intensity of usage, the log of the number of messages that they send, we actually find that they benefit more out there. So there's a negative effect on that interaction terms out there. It's significant out there. Okay, so that's the initial story, and this negative interaction could come from two sources. It could come from leveling up of low performers or leveling down of high performers. It's actually not leveling down of high performers. The high performers, when we do a sample split, high performers, it's insignificant. So it really is a leveling up story of the low performance. So we can triangulate that. I think this is the main identification that I buy. I think if we didn't have this, I probably would not be presenting this paper. We took their, so our previous CGPA out here is the term 1 CGPA, where everybody had the same course. We also have access to the term 2 CGPA, right? And that's a very similar outcome. If it's just basically a spurious correlation between performance and what we were finding out here with the usage, then something should have popped up out here, right? So when we make the term 2 GPA, where they had no agent, we didn't have this technology, right? There is actually no relationship between the intensity of usage and this one, right? So you can think of it as a very classic falsification test. If I have time, I can also talk to you about an instrument that we create. But let's see where we are with time. Okay, so it's kind of, at least it's starting to believe that this is a real thing that we're picking up. So with that main effect story, now let's look at a little bit into the details, into the mechanism. What we find is that Okay, perfect. So I'll be done in a minute. So what we find is that essentially, like I said, the exam has two parts. There is sort of an objective part, that's the technical part, and the application part. The heterogeneity, at least the leveling up, is only seen in the applied part of the exam. It is also seen, and again, they could use it in different formats. They could use it to prep for the exam. They could use it to actually do the casework. Again, the leveling up is seen when they actually do the casework, right? So I think these are the main findings. I've probably already talked about these contributions earlier, so I'll stop and take questions, actually. Yeah, Indy.
Right, this is very cool. I'm curious, and it's great that you did this with your exam as the way to test.
Yeah, which had no AI. It's a pen and paper, old school.
All the amazing things you guys do with industry and collaborative projects, why not test it with one of MBA students working on industry projects? Something real, where, you know what I'm wondering is, does the exam truly create a phenomenon that simulates what the real world is like?
Yeah, it's hard, I think, Hemant, because the projects, are very heterogeneous. In the teams of 5 students. One team is working on Best Buy, the other team is working on Medtronic. The evaluation there is also heterogeneous because most of these clients give great grades to the MBAs. So it's a little noisy measure. I see where you're going with this. I think we would love to see, for example, the effect of this on other things that we can measure out there. But yeah, fair point. Yeah.
The messages you're measuring is the messaging in the system, right?
Yeah, like the example I was showing you, that's a prompt. That, can you build a model to detect cancer, right? That's an example of a prompt.
I see. So, one of the questions I had is in your exam 2, or no, semester 2.
Yes.
When you didn't have the agent.
Yeah.
What was the significance of the message was?
It was not there. It was not there, right?
But then there was no messages in that, right? Because
Correct. And so that's a falsification kind of idea, right? So if there was a spurious correlation, if all I was picking up was some high performers, right? If there was something else driving performance, then then it should have shown up in that term 2 GPA also, right? But it's only showing up in the real regression. So it's like a fake regression basically. Yeah. Yeah.
Thank you so much, and please look for Professor Vanna during the coffee break. We're going directly to the second presentation.